Right, there we go. And we're rolling.
We seem to be missing.
Yeah.
It seems like when we last left off, we'd finished with the conceptual bit. Oh, no, we were about to do the test level problem, right?
Yes.
That was the last
Yeah,
thing.
the rubber wall.
You left us on a cliffhanger.
Yes, the flexible wall.
No, not this one. I get it.
We finished the ball.
What was the picture address?
We had finished the ball. And we had just started, drew this and labeled flexible wall.
Oh, we
The
had,
ball was gonna go towards it and bounce off it.
yeah, we said.
Oh, that's right, throwing. The ball was being thrown.
Yeah, the one we did before that was the ball being thrown straight up.
No, this is the person throws the ball against the wall and it bounces back. It starts from his hand and then
Yeah.
it's in. Yeah. All right. So we have A, B, C, D, E, F, and G. G and A are not at the same spot. Or formally, at time A, the ball is not at the same place as at time G. All right, so presumably you have in your notes the detail of what each of those points are. Now, as far as the wall goes, a number of people have difficulty sort of imagining it. So we have a ball that's being sent towards a wall, and it's gonna hit the wall, and so we have C is,
Moment just before the
Yeah.
ball touches the ball.
all right, so we have C is that moment just before it touches, and then it touches, and then you can either picture it as the wall flexes or the ball compresses some, but either way, that center of the ball is still moving to the left, or right, as you kids today say. So when it gets to point D, or at time D, that's the furthest right it's going to go before it starts to push back.
And it has 0 velocity.
Correct. That is the turnaround point.
Oh, okay.
So it is stopped at D, and then A is the very beginning, and then G is when the ball is stopped by hand. And see, F moment ball touches hand, and B is the last moment before leaving hand. So, hand, and then ball.
What was that? Just touching the hand?
B and F, it's still touching the hand.
Okay.
Just after B, or just after B and just before F, it's in space.
B is at the end of the forward and F is at the.
Yes. Yep. Now, in terms of format of presentation of answer, does anyone have a particular preference at the moment? All right. All right, so these are all the different times that we need to account for. We have the single letters, which are representing a specific moment in time, which was defined last time. And then we have the parts in parentheses, which indicate the times in between. So we have position, displacement, velocity, and acceleration. Let's see, this was my origin. So let's start with Brooke. You about to ask a question, or are you just thinking?
Oh, I was thinking, yeah.
Okay. Any questions before we look at this? All right, so what is position anyway, besides X, the way I'm doing it here?
It's where an object's at in relation to the origin.
Okay, and where's the origin?
Origin's at is that at the wall?
Yeah.
Just before, technically.
Okay.
So,
Saying 0 at C and E.
yep. Those are the only places, unless I screwed up, that we can go, where we go from positive to negative. So, on the other sides of those, it's either going to be plus or minus. I think I defined to the right as positive. Just so that we're all working on the same page. There's no particular reason other than habit.
So D is positive,
Yep.
and then everything else is negative.
So we know that's positive, therefore everything in between the zeros has to be positive as long as we've gotten those correct.
And then everything else is negative.
Okay. What about displacement?
Well, don't we have to identify where our starting point is?
Where's the starting point?
A.
Yeah,
Okay.
A is going to be the starting point.
So A is 0. And then for the rest of the time, it's positive.
Right, because it never goes past point A. To the plus. And again, when I'm asking for displacement here, I'm talking about overall displacement as default. All right, velocity. What do we know?
Change in position over time.
Okay,
So it would be yeah, because it's moving in a positive direction, right? Throughout A through D.
so what about an A and D?
At A is 0 and B is 0.
Okay. I generally recommend, you don't have to, I mean, you can start out with where's the positives, but generally recommend, let's figure out where 0 is first. I think that helps guide the rest of it. So it is 0 at the beginning, and it's 0 at D.
Isn't A the moment that the ball leaves the hand, though?
No, A is the moment that the hand starts to move it.
Okay.
B is the moment it leaves the hand.
Okay.
Yes, or just after B officially.
Yeah.
And is that it?
At G as well? G as well?
G as well. As the ball is thrown, so it's A, B, hits the wall, comes back, F, G. All right, and then you've identified this as positive to begin with.
Right.
And this is instantaneous velocity. Now, if I had asked for instantaneous displacement, what would that look like?
You have to pick a spot first. You have to pick one of the letters first to discuss.
No.
We talk about from one point to another.
Yeah, from one moment to the next.
Okay.
I mean, you have to move at the speed of light. What do you mean instantaneous displacement?
As in an infinitesimally small unit of time has passed.
Would that mean that our origin is shifting?
Yes.
Okay. Wouldn't it still be positive? Because it's
It would not look the same.
It would be positive as it was moving to the right, and negative as it was moving back to the left.
Yeah, so if I did instantaneous displacement, it would look exactly like velocity. If I asked instead of instantaneous velocity, or velocity as I call it, if I said average velocity, what would that look like?
0.
Would it be 0?
No.
Why not?
G is not FA.
The average velocity is not constant.
Well, but you said it's change in velocity over change in time, and change in time has been one point to the other. The change in velocity has gone from positive to negative, so it's canceled each other out.
So you're talking at the very end?
Yeah.
I was talking about as we went.
It would be positive, right?
I have no idea.
Change in velocity with change in time is acceleration. He's talking about, average velocity.
Oh,
Average velocity is change in position over change in time.
So you're looking for average velocity, but not at the end of this whole trial, just at any given moment, the average velocity.
Yes.
Wow.
okay. Well then,
Would it be positive because we are expecting the ball to slow down over the whole total thing? So it's slower in the negative direction than it is in the positive direction? So our average velocity is positive?
Oh, I see what you're saying. Really close.
Okay.
Yeah, other than, what's the exception to what I just heard you say?
That we're not giving any information about it slowing down, I guess?
Yeah, slowing down is irrelevant in terms of average velocity.
Well,
Well, it would look the same, wouldn't it?
As,
As the instantaneous velocity
Ooh.
in any given moment.
no.
Well, okay.
Would it look like
As the
The
position.
delta
displacement?
x?
Like
Yeah.
that.
Ah, look at me.
Because the average velocity is the total displacement divided by time, and so
And time
total
is
displacement
positive.
sign would be the same as average velocity. So average velocity as you go, which is constantly shifting, would look like this. Instantaneous displacement would look like that.
But why would it be positive when it's heading in the negative direction?
Average velocity cares about where are you relative to where you started. So when I'm at this point right here going that way, on average, I still have more positive than negative.
Because essentially the positive and negative direction has switched because of where your points of reference are. By points of reference, I mean, origin.
Would you have to go?
Word it slightly differently, I didn't quite follow everything you said, but I want to try one thing first and then
Yes.
give you another go, and then Michael.
Yeah.
So, from A to D, my average velocity is increasing, because I have more and more overall displacement. From D to G, my average velocity is still positive, but it's getting smaller. So if I think about the magnitude of my average velocity, I have a starting point here, and then I have a line going from this hand to this hand. So my average velocity is getting bigger, and then my average velocity is getting smaller. But my average velocity ultimately is never 0 again after it starts.
Unless you go past A.
Correct. And I don't. I stop before I get there.
Okay, so if the displacement was negative and then time is obviously positive, it would be negative.
Average velocity would be, yes.
Average, you're saying, what'd you just say, the average velocity would be negative if we went past the starting point?
Yes.
So we have more negative velocity time.
Correct.
So,
That was-
so even when the average
That's
velocity
what
was
will make it negative.
Yes.
Okay.
All right. However, Anna, want to come back to you,
Still struggling with why it's always positive.
other than at the very beginning.
Yeah, I feel like I totally see why it would be positive when it's moving in a positive direction, but I'm struggling with why it would not then be negative when it's heading in what I think is still the negative direction.
All right. Average velocity is total displacement over time, as opposed to instantaneous velocity, which is instantaneous displacement or instantaneous change in position over time. So if I go from here to here, at this point right here, my instantaneous velocity is negative because in an infinitesimally small amount of time, I'm moving to the left. However, ultimately, I'm still, if that's my starting point, I'm still on the positive side.
Okay, okay.
So
The starting
even though-
point is staying exactly in the same place.
For average velocity,
For
yes.
average velocity, okay, I follow you, I got it.
Okay,
Yeah.
sorry if I misunderstood earlier.
No, I think I misunderstood, thank you.
All right. Actually, in order, Michael, you had something.
Well, you pretty much got it by saying going past A, but I was also thinking of it as like, basically if you didn't catch the ball, if the ball went past you,
Yeah.
then you would have negative. But
Negative
otherwise, it would be positive because the ball's only coming as far as you are.
Because
Your starting point.
Right.
if it went past you, you'd have more negative distance than positive.
Negative displacement, I prefer over
Over
displacement.
displacement, okay.
Wouldn't it
Brooke?
also then be zero? I'm so
Sorry.
sorry.
Ordinarily, I have no problem people chiming in with questions, but some people are raising hands, so I wanna make sure I get them too.
Well, average
So-
is looking at a bigger picture, is looking at the overall picture,
Yes. Yeah.
not just like instantaneous, a little piece.
Remember my being as fast as Usain Bolt. Average looks at the whole picture, not just
Right.
any particular moment, because then I don't think it'd be much contest. Brooke,
I just wanted to ask, you said the instantaneous velocity, this little drawing right there, did you say that was positive or negative?
this would be negative.
Because it's, because you're like moving this way,
Yes.
but you're still, but it's relevant to the starting point, okay, makes sense.
Okay, Anna?
So we have established that it, would look the same as the displacement, but I feel like G would be zero then as well.
G is not quite as far back. A is here, G is just slightly
Oh,
ahead
that's
of
right,
it.
okay.
Okay,
Yep,
so
It's when the ball hits the,
is this an easier way of thinking about it? When it's instantaneous velocity, it's dealing with what direction you're going. When it's average velocity, it's dealing with how far you are from the starting point.
And
Or
which
where-
direction you are.
In
from the
which
starting
direction you are from the starting point.
point. Yes,
Okay,
alright. Just to let you know, when you have the complex problem like this, I'm not gonna ask for average velocity and not gonna ask for instantaneous displacement. That was just sort of a side note to try to put some of the pieces together. Hopefully it put them together instead of taking them apart, but
Both have to do it.
It's fine.
you'll be able to watch this again and again and share it with your grandkids at some point.
Can you, repeat what he just said?
You want me to repeat it?
With how,
Cause you like simplified it, yeah.
instantaneous is, I mean, how average is how far you are from the starting point, and it considers the direction,
Yes.
but then instantaneous is what?
It also considers direction. Instantaneous is in which direction you're moving. That's instantaneous.
Okay.
Average velocity cares about where are you relative to where you started. I'm on the plus side or the minus side.
So instantaneous doesn't take into account like how far you are, it's the direction.
Well, the direction cares about the direction you're actually moving for instantaneous. If you actually want to put numbers on it, then let's do a quick lesson in calculus.
no, thank you.
Oh boy.
Who did that?
We're not gonna go through a derivative, I mean, not the math of a derivative, just we'll go through the concept here.
Right,
So I have, so let's say I'm starting here, so this is position and time. Oh, what the heck, let's make it displacement. So let's say that this is what my position looks like. So first time, so I start here, I move up, and then I move down, then I move up, and then I move down. So it's one-dimensional motion, just moving up and down, and this is where I am at some particular time. Velocity. Instantaneous velocity talks about an instant. Now mathematically, what does an instant actually mean? I've defined velocity as change in position over change in time. Instantaneous is when you let this right here, as good as always. When you let the change in time, the math term is the limit as delta t goes to 0.
oh, yeah,
So you're letting this change in time not equal to 0, just incredibly small. Think of whatever small number you can think of and make it smaller. And in that change in time, how much does your position change? Not gonna change much, but time's not changing much either. So you have this tiny number divided by a tiny number, which usually comes out to be, well, in a math problem that's definable, it comes out to something that you can actually pop into a calculator. So if I want to find the instantaneous velocity at this point right here, what I'm looking for is, in essence, I take, this is some moment of time, and I basically look at some tiny change in time here. This is, I'm going further into the math than I intended. This is t plus h, and this would be t minus h. There are a couple other ways of doing this. You're letting h be incredibly tiny. You have this, you're looking at basically a slope of the line of the tangent. There we go. So if I have a point right here, the tangent line just barely skims at that point. The slope of that line is my velocity. However, average, if I'm at this point right here, I want to figure out average velocity. Look at all this. Oh.
I think behind it counts too, doesn't it?
Sure, yeah. All the great players started that way, right?
Yeah.
Average velocity is looking at the slope of this line right here. We have a change, the overall displacement, and over time. Rise over run. That's why I'm talking about the slope, it's rise over run. So instantaneous is looking at the slope of the tangent line. Average is looking at the slope of, well, basically a line from where you started to where you are at that moment. I don't know if that cleared it up at all, but it's a different way of looking at the exact same thing.
Like, I think it helps, but I would need more examples, like practice, to make sure it's like cemented, to make sure it like makes sense.
I did get that better.
Do I? No. I'm done with calculus. I mean, like, yeah, never mind.
Yeah, so for those of you who end up taking Cap 1, you look forward to this and you go, oh, okay, that's what he was talking about.
Yes.
No,
For those who aren't gonna take calculus and you just let it ruminate in the back of your head, and then when your kids are taking calculus, you go, oh, that's what he was talking about.
Yeah. The way I would view that is, you got a guy with a line or a dot on the line you're plotting, but the line of the dot has no width.
The line of the dot.
The line or the dot,
Oh.
depending on how you mark it.